scarcely been shipped off, and the universe is now presenting us with another mystery in the boundlessness of space. A confusing guest has caught our eye and bewildered scientists across the planet. While cosmologists and space experts endeavored to figure out this odd interstellar object upon its first appearance, the James Webb Space Telescope, JWST, has since changed the record books. The JWST has widened our window into the universe and captured the first certified picture of Oumuamua, the confusing interstellar object that ignited countless conversations. Yet, what definitively is this extraordinary guest from space, and might it have had a magnificent origin, as some experts are now guessing? Join us on this invigorating excursion as we uncover the privileged secrets stowed away inside Oumuamua's surface and disentangle the reality behind this intergalactic puzzler. This will be one mind-bending experience that will challenge everything we thought we knew about our situation in the universe. Imagine an object unlike anything we've ever seen, rising up from the farthest corners of space. It is an elongated, cigar-shaped vagabond, bearing not an inconceivable explanation but appearing to be a slight, tremendous needle or a giant cigar. Its odd appearance piques our interest, leaving us anxious to uncover the secrets buried within its extraterrestrial origins. Everything began on the simple evening of October 19, 2017, when the Pan-STARRS 1 telescope, perched high in the mountains of Hawaii, extended its gaze toward the sky. Little did space experts know that this would mark a remarkable moment in the way we grasp the universe. In a shocking discovery, Pan-STARRS 1 uncovered the presence of Oumuamua, an object like no other. Imagine the sheer significance of this discovery. It was the first time we had identified an interstellar object far away from space, quite far beyond our nearby planetary group. Yet, substantially more staggering was the fact that this superb vagabond had crossed the incredible depths of space, challenging all odds to enter our solar system and advance toward Earth. Oumuamua's startling appearance sent shockwaves through the scientific community, marking its place in the archives of discovery. The implications were colossal, as the shimmering guest held the possibility to open the very secrets that lie hidden inside our vast universe. That is why capturing a genuine picture of Oumuamua became an obsession. It was a remarkable achievement as we sought more information, yet make no mistake, space experts knew that the endeavor didn't end with a picture. The determined mission to figure out Oumuamua led cosmologists to the wondrous James Webb Space Telescope. This mechanical marvel is set to disentangle the mysteries of interstellar objects as they discreetly pass through our planetary system. The JWST has an unmatched capacity to gather and investigate infrared light, a critical instrument for the investigations ahead. Furnished with top-level high-resolution and profoundly delicate instruments, the Webb telescope opens up a vast scope of possibilities. Its unmatched responsiveness empowers cosmologists to notice objects that were once thought to be too old, too far away, or too weak for other telescopes to capture. With this remarkable power, an entirely new universe of investigation spreads out before us, permitting us to dive deep into the mysteries of interstellar objects. From the perspective of the Webb telescope, we can uncover the secret of substances, associations, and reveal the true essence of these unusual space voyagers. Such fine details would be challenging to see from Earth alone, as we require close-up observation to fully appreciate their crucial insider facts. Like a sharp eye in the universe, this incredible instrument reveals a degree of clarity that uncovers details, enlightening these enchanting, perpetual guests as interstellar objects float within our observational reach. The Webb telescope becomes our dedicated guide, capturing their essence in ways that transcend simple images. It consistently joins hundreds, if not thousands, of images to create a super high-resolution picture that embodies all we hope to see. By harnessing the telescope's power, we can investigate the smallest and most captivating portions of these interstellar objects, unraveling secrets that have remained hidden for eons. The James Webb Space Telescope isn't just an instrument for scientific inquiry. It is a gateway to remarkable discoveries. With its extraordinary abilities, this mechanical wonder allows researchers to test the depths of space at scales and levels of brightness that were once far out of reach. It's like opening an entirely new chapter in the universe, paving the way for genuinely exciting scientific investigations. By harnessing the power of the Webb telescope, researchers are determined to push the limits of our understanding and curiosity about the universe, uncovering mysteries that have remained concealed for ages. Therefore, the James Webb Space Telescope was chosen for this significant investigation, pushing the boundaries of inquiry and taking us deeper into the realms of revelation. However, we should pause to appreciate the exceptional capabilities of the Pan-STARRS-1 telescope. While it may differ from the James Webb Space Telescope, it is an astounding instrument in its own right. Located at the top of Halakala on the beautiful island of Maui, Hawaii, the University of Hawaii's Pan-STARRS-1 telescope stands as a testament to human ingenuity. With its primary 1.8-meter width, this telescope plays a critical role in the ambitious Pan-STARRS project, a collaborative effort involving renowned institutions such as the University of Hawaii's Institute for Astronomy, MIT Lincoln Laboratory, the Maui High Performance Computing Center, and the Science Applications International Corporation, SAIC. Together, they endeavor to unlock the secrets of the universe, combining their expertise to harness the tremendous power of this colossal wonder. Looking at the grand design and abilities of the Pan-STARRS-1 telescope, it is a true master of wide-field imaging, uncovering the brilliant wonders of our universe. Its mission is clear: to conduct extensive sky surveys, capturing the breathtaking phenomena that enhance our brilliant scene in astonishing optical frequencies. From the dazzling shine of distant galaxies to the mesmerizing patterns of swirling nebulae, and from faraway comets exploring the vastness of space to the quiet journey of asteroids, this dedicated telescope scans the universe, recording the intricate details that populate our vast cosmos. The Pan-STARRS-1 telescope relies on the advanced PS-1 image processing pipeline, IPP, to handle the enormous amounts of data gathered during these surveys. This crucial tool ensures the efficient and accurate processing of the captured celestial images. It is a leap forward in software, enabling the study of massive amounts of observational data, extracting vital insights and empowering space experts to make indispensable discoveries. The mysteries hidden within the vast number of celestial images captured by Pan-STARRS-1 are revealed through the power of cutting-edge calculations and numerical methods. One of its most impressive features is its involvement in the Pan-STARRS Near-Earth Object (NEO) survey. This ambitious effort systematically examines the entire sky north of declination -47.5 degrees, looking for near-Earth objects, NEOs, that could pose a threat to our planet. This study serves as a defense for humanity, and it was within this vigilant watch that Pan-STARRS-1 made its groundbreaking discovery of Oumuamua, marking a pivotal moment in our mission to understand the mystery that surrounds us. Sometimes, the most surprising discoveries emerge out of nowhere, and that was the case with the discovery of Oumuamua by the Pan-STARRS-1 telescope. While it was diligently performing its primary duties, this astounding telescope randomly detected this surprising visitor. Initially, experts believed they had identified an approaching asteroid, a common event in the infinity of space. However, as they delved deeper into the gathered data, a startling truth began to emerge. Oumuamua, with its strange rock-like appearance and odd behavior, defied the standard assumptions for a typical asteroid. This unprecedented traveler had a story to tell, and it was far from ordinary. The more the data was processed and analyzed, the clearer it became that this mysterious interstellar object had a nature that surpassed all expectations. Its sudden changes in trajectory left researchers bewildered and sparked a flurry of stunning questions about the true nature of Oumuamua. The urgency mounted quickly as the staggering visitor sped through our planetary system at confounding rates. Each passing second became crucial, as time was rapidly running out for the scientists, with only a mere 11 days to gather as much data as possible about this complex cosmic vagabond before it wandered too far to focus on anymore. The urgency was real. With each tick of the clock, the window for data collection became smaller and smaller. Intense scrutiny became essential, and the pressure mounted within the research team as they knew that any delay, no matter how small, could jeopardize their observation of this brilliant anomaly. In their mission to uncover the puzzling properties of Oumuamua, NASA enlisted the help of the European Southern Observatory's Very Large Telescope in Chile. This remarkable instrument became the primary observation site on a journey of precise measurements and detailed analysis. With tireless determination, it aimed to uncover the secrets hidden within Oumuamua. Its color tone, brightness, and every aspect of its surface and structure held crucial significance. This was no ordinary rock. It was an object that had captured the imagination of scientists worldwide. With the combined efforts of NASA and the ESO's Very Large Telescope, the stage was set for observations that would reveal the astonishing truth concealed inside this celestial mystery. The trial of skill and perseverance intensified as the observations began. The Very Large Telescope, with its unparalleled accuracy and cutting-edge technology, meticulously examined Oumuamua, inch by inch, pixel by pixel, searching for any clues that could reveal its true nature. The telescope's instruments investigated the celestial guest's true properties, providing valuable data that would contribute to a clearer understanding of its origins and composition. It was at this crucial moment that Oumuamua's length and shape came into sharp focus. A captivating realization began to take shape. This unprecedented object exhibited a highly elongated, cigar-like shape. The more data that poured in, the more unmistakable it became. Far from being a standard asteroid or comet, it was something entirely alien, an interstellar voyager whose history traced back to distant star systems. But this was just the beginning of the journey. What Oumuamua truly was and why it behaved in such strange ways remained a matter of intense speculation. As the investigation of Oumuamua continued, space experts were struck by an even more perplexing aspect of its behavior: its unexplained acceleration. Normally, objects like asteroids or comets follow predictable paths dictated by the gravitational forces of the Sun. However, Oumuamua did not adhere to these expectations. As it sped through our solar system, it appeared to accelerate, speeding up in a way that could not be fully explained by gravitational forces alone. Initially, scientists thought this might be a result of the object's interaction with the Sun's radiation pressure. This phenomenon, known as the Yarkovsky effect, occurs when sunlight strikes an object and causes it to release heat, which pushes it in a specific direction. However, the acceleration of Oumuamua was too great to be explained by this effect alone. Some scholars even theorized that there might be another explanation entirely. Perhaps the possibility that Oumuamua was not a natural object at all, but rather a piece of artificial technology sent by an advanced extraterrestrial civilization. While such a theory remains highly speculative, the possibility of extraterrestrial origins for Oumuamua ignited a whirlwind of discussions in the scientific community and the media. Some argued that its strange shape, unexpected acceleration, and high speed all pointed to an artificial origin, perhaps even an extraterrestrial probe sent to explore our solar system. These bold claims were met with both excitement and skepticism as the academic community debated the possible explanations for Oumuamua's bizarre behavior. Nonetheless, despite the many theories, one thing remains certain: Oumuamua was an object unlike any we had encountered before. Its sudden appearance and puzzling properties made it a landmark discovery, offering tantalizing glimpses into the nature of interstellar objects and the possibilities for life beyond Earth. As the investigation into Oumuamua deepened, the scientific community faced mounting challenges in explaining its peculiar characteristics. With every new discovery about the object, the mystery grew more intricate. One key question remained at the forefront: what was causing its unusual acceleration as it sped through the solar system? Traditional models of gravitational interaction and solar radiation pressure could not fully explain the force driving its increased velocity. This led researchers to consider more unconventional theories, which in turn sparked debates within the scientific world. One of the more fascinating hypotheses proposed by some researchers was that Oumuamua might not be a solid object at all, but instead a type of space debris composed of materials we are not yet familiar with. Perhaps it was a fragment of a larger, disintegrating body, or an object composed of porous, lightweight material that would allow for the acceleration observed. Alternatively, the object's acceleration might be due to an interaction with the interstellar medium itself. As Oumuamua passed through our solar system, it could have been subject to pressure from cosmic rays or magnetic fields, forces we have yet to fully understand. Adding to the enigma, The object exhibited no visible comet-like tail, which would be expected if it were composed of volatile materials like a comet. Comets typically release gas and dust as they approach the sun, forming a visible tail that can be detected from Earth. Yet, Oumuamua showed no such behavior, which made it all the more mysterious. This absence of a tail led some researchers to speculate that the object's movement was driven by factors other than typical solar radiation, possibly involving more exotic forces such as those associated with dark matter or even antimatter. Meanwhile, the possibility of Oumuamua being an artificial object, perhaps a probe sent by an advanced alien civilization, continued to stir excitement. Some proponents of this theory pointed to the object's elongated shape as being too perfectly unusual to be the product of natural processes. Additionally, its high speed and trajectory, which did not align with the predictable orbits of asteroids or comets, suggested that it might have been intentionally directed. Although this hypothesis remains speculative, it opened up exciting discussions about the potential for extraterrestrial life and the possibility of contact with other civilizations beyond our planet. In parallel to these more outlandish ideas, many scientists continued to focus on the more plausible natural explanations. A number of researchers suggested that Oumuamua might be a fragment of a larger body that had been torn apart during its passage through the dense regions of space between stars. This would mean that the object had traveled vast distances, possibly millions of years, before it arrived in our solar system. With such a long and complex journey, it's conceivable that Oumuamua might have undergone some dramatic physical transformations, which contributed to its unusual appearance and behavior. What seemed certain, however, was that Oumuamua had challenged everything we thought we knew about objects from beyond our solar system. Its appearance and behavior forced scientists to rethink the very nature of interstellar space and the objects that populate it. More data from advanced instruments like the JWST will undoubtedly continue to shed light on Oumuamua and other interstellar visitors, but the legacy of this mysterious object will live on in the minds of researchers and the public alike. It opened a new chapter in the exploration of our universe, one that promises to be filled with even more astonishing discoveries about the unknowns of space.